Proofora is a batch verification prototype for Stellar and Soroban. It is built for applications that need to apply multiple proof-backed actions without sending one contract invocation for every single proof. The problem is simple. If an application verifies n independent attestations, eligibility checks, private voting actions, identity claims, or proof-derived state transitions, the naive path submits n separate transactions or contract calls. That repeats ledger inclusion, authorization, and application overhead for every item. Proofora places a batch boundary between proof production and on-chain application. Off-chain, each action produces a proof envelope and a public input. Each public input is converted into a fixed 32-byte leaf. The ordered leaves are concatenated and committed with SHA-256 into one deterministic batch root. On-chain, a Soroban contract receives the proof envelopes, public input leaves, and the expected root. The contract checks that the batch is not empty, that proof and public input counts match, that each proof envelope has valid fallback structure, and that the recomputed root equals the submitted root. If the batch passes, the contract returns a receipt containing the accepted root and the number of inputs. The important claim is precise. Proofora demonstrates an n-to-1 transaction path and deterministic public input integrity on Stellar testnet. It is not claiming recursive proof compression. The deployed fallback validates envelope shape and root integrity while preserving a clean interface that can later be connected to a production proof verifier.
Now we move to the live Proofora demo at prooforabatch.versal.app.
The dashboard loads live Stellar testnet data through Soroban RPC. At the top, it shows the latest observed ledger, the deployed contract hash, and the recorded batch size. The demo links directly to Stellar Expert, so the contract and transaction evidence can be inspected independently. I click Run Fallback Verification. In the browser, Proofora recomputes the n equals 2 batch root from the recorded public inputs, compares that local result with the on-chain return value, and reports the receipt status. The terminal shows the local batch root computation, the on-chain root comparison, and a pass result. The receipt confirms that the root matched and that 2 proof-backed inputs were accepted as one batch. The benchmark panel shows the general effect of the batching path. 2, 4, or 8 individual submissions can be represented by one batch submission. The demo also keeps the trust boundary visible, so judges can see exactly what is on-chain, what is local fallback logic, and what is future verifier work. Finally, we open the Stellar testnet transaction. This is the recorded verify MADI call for the deployed Soroban contract. It anchors the demo to real on-chain evidence, not a static mock. Proofora is therefore a complete proof of concept for reducing proof-backed application submissions from n transactions to one deterministic, verifiable batch transaction on Stellar.